We're going to look at some more shapes and finding surface area of these other shapes that we've talked about already, but now we're going to learn how to do their surface area. So first we're going to start with pyramids, and then we'll talk about cones. So what I've got here is, this is what a pyramid would look like. This is a square pyramid because it's got a square base. If you notice, when I make the net of the pyramid, there's a triangle that comes off of each side. And in this case, all the triangles are the same because my pyramid is centered. Okay, the peak of the pyramid is centered above the square. So in order to find surface area, we're going to need to find the area of the base, and then we're going to have the area of each of these triangles. Okay, and the area of the triangle, remember, is 1/2 base times height. This base is actually our side length. So it'd be 1/2 the side times the height. Now make sure that when you're doing triangle, we want this blue height, okay, which is actually called the slant height. Okay, we don't want this height because that isn't part of our triangle. Okay, because this is my triangle. The blue line here is the blue line here. That's the height I want. So here's an example. This is a hexagonal pyramid. So I've got a hexagon for a bottom. So if I draw my net, I have to draw a hexagon. Okay, and each side is 8. And then each one of these has a triangle coming off. So it looks kind of like the sun. Okay, and I want the slant height here, which is 18. So this would be 18. And then it also gives me my apothem here. My apothem is 4 square root 3. So first I'm going to find the area of the hexagon, which is 1/2 apothem times perimeter. The perimeter would be 8 times 6, which is 48. So half of 40 is 24. Times 4 is 96. So we got 96 square root of 3. And then the area of one triangle would be 1/2 the base, which is a side, times the height, which would be 18, which equals 72. And then I've got 6 of these. So that would be 216 times 2, which is 432. So that's the triangles. Then I have to add in this. Let's get the calculator here, because we want a decimal. So we got 432 plus 96 square root of 3. So we get 598.2728 actually. Okay, and that would be in, since this is inches, this would be inches squared, because area is always square inches. Okay, so that's how you deal with pyramids. Now let's look at cones. So if I want to find the surface area of cones, right, I'm going to break it up into 2 parts. I've got a circular base here, so here's my base. And then I've got the cone part, which if I lay flat would look kind of like Pac-Man here. And L, which is the slant height here, would be this. Now, in order to find the area of this, I'm going to have to know what the area of the whole thing is, and I have to know how many degrees this is, which I don't know. So what we're actually going to do is we're going to use our circle, because this edge here, okay, the curved part, is just long enough to go around my circular base, which means it would have a length of 2 pi r, okay? So we're going to use that. So this is 2 pi r, okay? And if I take and try to find the area of this, I can set up a proportion. Okay, in the proportion that we're going to set up, okay, so I've got arc length. Okay, so I've got arc length. Okay, and this is going back to our last chapter. If I have arc length, I should be able to make that into a fraction with the circumference. Okay, and if you remember last chapter, this ratio would be the same as degrees over 360, or it could equal area of the sector over area of the whole circle. Okay, so we don't have any degrees, so we can't use this, but we can get enough information with these two to solve for the area of this. Okay, so the arc length of the piece I've got is 2 pi r. Remember, r is the radius of this circle. So 2 pi r. So even though it's the circumference of my circle, it only represents the arc length of this arc here. If I put that over the circumference of this circle, if the whole circle is there, the circumference of this circle with a radius of L would be 2 pi L. Okay, since I have a radius of L, it's 2 pi times the radius, okay, which is L now. And this should equal the area of this piece, which we don't know, over the area of this whole big circle here, which would be pi L squared. And then I just have to solve this for x. Okay, now you're not going to have to go through this every time. When we're done with this, since we're using generic variables for each of these measurements, we'll have a general formula to find the area of the cone part. Okay, so I'm just showing you where that comes from. When I cross multiply here, actually before I cross multiply, I'm going to cancel the 2 pi out here. So I've got r over L equals x over pi L squared. Now I cross multiply, so I get r pi L squared equals Lx. I can divide by an L, so I get x equals, let's rearrange it, pi r L. That would be the area of the cone part. So that means the surface area of a cone is the area of the cone plus the area of the base, which is pi r squared. Okay, so you're going to write this formula down. This is how you're always going to find surface area of a cone. So let's look at an example of that. So here they gave me height, but this is not my slant height. I need L. Okay, remember L is the slant height. They give me the radius. Okay, so r equals 7. I need to find L. I can do that with Pythagorean theorem. 7 squared plus 24 squared is going to be 625, and if you square root it, you're going to get 25. Okay, I'll just show you that quick. 49 plus 24 squared, 625. The square root of 625 is 25. Okay, that's one of the Pythagorean triples, which is why I knew it. 7, 24, 25 is Pythagorean triple. So now I've got L. So now to find surface area, I'm going to take pi times my radius times my slant height, and I'm going to add pi times my radius squared. So I've got pi times 7 times 25 plus pi times 7 squared. And there's my surface area, 703.72. And whatever the units were here, let's say they're meters, this would be meters squared. And that's surface area of cones and pyramids.